Cape Canaveral buzzed with anticipation as a SpaceX Falcon 9 stood ready for a historic launch. This was no ordinary mission. 3 spacecraft, each with a unique purpose, were set to journey toward the sun. The world watched as the countdown reached 0, and the Falcon 9 roared to life, lifting off in a blaze of fire and ambition. Onboard IMAP, SWFO L1, and the Carruthers Geocorona Observatory, 3 robotic explorers, each vital to understanding the sun's impact on Earth. Their destination, 1 million miles from Earth, at a vantage point to observe the sun like never before. This mission, a collaboration between NASA and SpaceX, aimed to safeguard our technology and deepen our knowledge of the sun's influence. As the rocket soared, it carried the hopes of thousands of scientists and engineers, marking a new era in heliophysics. These spacecraft would work together, providing the most comprehensive view yet of the Sun-Earth connection. Understanding the sun is key to protecting our world and preparing for future space exploration. This triple launch signaled a bold step forward in unlocking the secrets of our star. The launch was just the beginning of a carefully orchestrated mission. After Falcon 9's first stage landed for reuse, the second stage propelled the trio deeper into space. Deployment began. IMAP was released first, signaling its readiness for a grand quest to map the solar system's boundaries. Next, SWFO L1 separated, setting off to become our frontline defense against solar storms. Finally, the Carruthers Geocorona Observatory was deployed, ready to study Earth's outermost atmospheric layer. Each successful deployment brought cheers and relief, every step critical to the mission's success. Their journey to Lagrange Point 1, 1 million miles from Earth, had begun. At L1, the gravitational balance allows for continuous observation of the sun. Over the coming months, engineers would calibrate instruments and fine-tune trajectories. The trio's arrival at L1 would mark the start of groundbreaking science. This mission's timeline is a testament to precision, teamwork, and the promise of discovery. IMAP, the Interstellar Mapping and Acceleration Probe, is the mission's star. Its goal to map the boundaries of the heliosphere, the sun's protective bubble shielding us from interstellar radiation. IMAP's 10 instruments will capture and analyze particles from both the sun and distant stars, revealing the structure and dynamics of our cosmic neighborhood. By studying how particles are accelerated to high energies, IMAP will help us predict threats to astronauts and satellites. It's a cosmic detective piecing together clues about the invisible forces shaping our solar system. IMAP's data will be crucial for planning future missions beyond Earth, ensuring explorers' safety. Like ancient mariners mapping the seas, IMAP charts the space environment for the next generation. Its discoveries will revolutionize our understanding of how the sun connects us to the galaxy. IMAP is more than a spacecraft. It's our guide to the unknown. With IMAP, we're drawing the first true map of our solar system's frontier. SWFO L1 is our planet's vigilant space weather sentinel. Stationed at L1, it provides early warnings of solar storms, critical for protecting our technology. Like a meteorologist for space, SWFO L1 tracks coronal mass ejections and solar wind in real time. Its coronagraph blocks the sun's glare, allowing it to spot storms as they erupt. With up to an hour's notice, SWFO L1 gives power grids, satellites, and airlines time to prepare. Its instruments measure the speed, density, and magnetic field of incoming solar particles. This data is vital for forecasting the severity of space weather impacts on Earth. SWFO L1's mission is practical and essential, safeguarding our infrastructure and daily life. It stands guard, ensuring our society remains resilient against the sun's unpredictable outbursts. SWFO L1 is the unsung hero keeping our modern world running smoothly. The Carruthers Geocorona Observatory, named for Dr. George Carruthers, studies Earth's elusive geocorona. This faint hydrogen cloud forms the outermost layer of our atmosphere, invisible from the ground but vast in scale. From L1, Carruthers will capture ultraviolet images of the geocorona, mapping its shape and changes. Understanding the geocorona helps astronomers correct for its interference in space observations. It also reveals how Earth's atmosphere interacts with solar storms, complementing data from IMAP and SWFO L1. Together, these missions trace the journey of solar storms from the sun to Earth's edge. Carruthers' insights will improve our models of space weather and atmospheric loss. This observatory completes the chain, giving us a holistic view of the Sun-Earth connection. These missions are more than scientific. They're vital for protecting our technology-driven lives. Solar storms threaten power grids, satellites, and GPS systems that underpin modern society. SWFO L1's warnings allow utilities to shield equipment, preventing blackouts and infrastructure damage. IMAP and Carruthers provide data to safeguard satellites and ensure reliable navigation and communication. As we plan for human missions to the Moon and Mars, forecasting solar radiation becomes critical for astronaut safety. The trio's data will help shield future explorers from dangerous solar events. By understanding and predicting space weather, we secure our present and future. These sentinels stand watch, defending our world from the sun's hidden dangers. The launch of IMAP, SWFO L1, and Carruthers marks a new era in solar science and planetary protection. This collaboration unites scientific discovery with practical defense, ensuring a safer, more resilient future. Each spacecraft fills a unique role, mapping, monitoring, and observing the Sun-Earth system in unprecedented detail. Their combined data will transform our understanding, inspire new generations, and support humanity's expansion into space. As we become a multi-planetary species, forecasting space weather will be as essential as predicting storms on Earth. These missions are an investment in exploration, safety, and the enduring human spirit. With new eyes on the sun, we're closer than ever to unlocking its secrets. This is a new dawn, one that promises discovery, security, and a brighter future for all.